The James Webb Telescope, JWST, has provided humanity with unparalleled views of the distant universe during the past few weeks. And surprisingly, some of these dazzling new sightings have raised more questions than they have answered. But what could be the future of our planet from the recent observations made with the James Webb Telescope? So make sure to stick with us till the end. Suppose the recent discovery of early galaxies with the JWST, the James Webb Telescope, proves to be just the tip of the iceberg. In that case, it could add significantly to the debate between those who think dark matter exists and those who think dark matter doesn't exist. On the contrary, it is necessary to modify the laws of gravity and mechanics to describe the origin and behavior of galaxies. The MOD hypothesis, which is an alternative to the idea of dark matter, correctly predicted the finding of these galaxies. Thus, we know for sure that it happened. For a long time, for example, scientists believe that the oldest galaxies in the universe were small, slightly chaotic, and misshapen systems. But according to the Washington Post, images captured by JWST revealed that these galaxies were incredibly massive, not to mention balanced and well-formed. This is a finding that challenges and will likely rewrite long-standing knowledge about the origins of our universe. Let's quickly take a look at the basic details of the James Webb Telescope. Astronomy allows us to determine very specific details about the universe, such as the fact that our sun is composed of 91.2% hydrogen, or that there was water vapor in the atmosphere of WASP-39b, a planet located 700 light-years from us. All of this is possible thanks to spectroscopy. The James Webb Space Telescope is able to make analyses thanks to this scientific method based on the study of color and its wavelengths via its NIRSpec instrument provided by the European Space Agency, the ESA. The James Webb Space Telescope is the most advanced and powerful space telescope that has ever been constructed, being the result of an international collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, the CSA. It is used by astronomers around the world. The power of the Webb telescope helps scientists discover other worlds, like exoplanets, learn about life cycles of stars, paint a fascinating picture of the dawn of the universe, and observe evolution galaxies in time. The James Webb Telescope enables scientists to study the planets of the solar system and other planetary systems in unparalleled detail. It aims to determine what elements these planets are made up of and to reveal whether the conditions on these worlds are favorable for life. The telescope could even detect signs of extraterrestrial life known as biosignatures. As it is possible to observe the universe in the infrared with the Webb telescope, scientists can also study planetary systems in formation. These young systems, called protoplanetary disks, contain dust that blocks visible light and can only be studied using instruments like those of the James Webb Telescope. Now let me take you back to 2019. Trust me, it will be an interesting ride. Just stick with me till the end. The great 2019 Nobel Prize in Physics was given to a cosmologist, James Peebles, who many considered to be one of the main fathers of the cosmological standard model, with dark matter and a constant in the equations of general relativity denoted that Einstein had introduced into the very first model of cosmology built from his relativistic theory of gravitation in 1917. This constant has been accelerating for a few billion years in the observable cosmos, when it had to decelerate from the Big Bang, or so we thought. The standard cosmological model is for these reasons called the lambda CDM model, CDM being an acronym in English for cold dark matter. Observations of the cosmic radiation by the Planck satellite in particular strongly support the standard cosmological model. Some may therefore be confused by the statement made on his Twitter account by the famous American astrophysicist and cosmologist Stacy McGough, who is well known for his work based on the MOND theory, acronym for Modified Newtonian Dynamics, and which therefore studies galaxies, dark matter, and theories of gravity modified as an alternative to the existence of dark matter. These statements accompany the announcement of the discovery in the first images of the James Webb Space Telescope, the JWST, of two galaxies, one of which is the most distant known to date. It is possible that the Subaru telescope has detected a galaxy more far away yet, however, or at least which breaks the own record at the Hubble telescope on this subject. Recall that cosmologists are used to expressing a distance for galaxies to the Milky Way by means of a parameter denoted z, and which is a measure of their spectral redshift. The higher z, the more distant the galaxy. That being said, let's look at what the James Webb Telescope could have found. The prevalent view that early galaxies were realms of disorder and randomness has been evidently verified magnified by older photos of the cosmos recorded by the Hubble Space Telescope, which was recently dethroned as the most powerful observatory telescope in the world. The James Webb Telescope, however, appears to show that these findings were an illusion based on Hubble's limited capabilities. Although these findings have taken the scientific community by surprise, they are not at all alarming. Major technological advances in astronomy and beyond have long led to periods of large-scale scientific discovery. It clearly does feel like one of those watershed moments right now, and discoveries made today could well lay the groundwork for future breakthroughs, even if they are decades away. And really, discoveries like this mean that the James Webb Telescope is doing exactly what scientists want it to do. It's revealing exciting new things about our incredibly vast universe, answering the old questions and asking new ones. Next up, the future of James Webb Telescope. The James Webb Telescope should make it possible to observe distant objects never observed so far. And in space, to look very far is to look into the past. It's a bit like a time machine. Another expectation from the James Webb Telescope is that it should provide even more precise images with a sensitivity 100 times greater than Hubble. By pointing the telescope at the right place, astronomers hope to get as close as possible to the first galaxies, which formed barely 100 million years after the Big Bang. Does that sound like it's a lot to you? Scientists are going to get very close to the origins of the structure of galaxies. The objective is to understand how they were formed, why they took these various shapes, such as spirals, ellipses, and others, and also how the material is organized. These observations could also make it possible to learn more about the first galaxies, even closer to the Big Bang, which are not observable. Will the James Webb Telescope tell scientists how stars and their systems are formed? The James Webb Telescope could make visible what is currently hidden from our eyes, namely the formation of stars like our sun. Star formation in galaxies takes place in regions of very dense gas, in which there is a lot of dust. These regions are therefore very difficult to observe for telescopes like Hubble. In the infrared, scientists can better penetrate these regions. They will be able to look 10 billion years ago, when galaxies formed most of their stars. In the universe, stars are continuously produced, but scientists do not know how they form, and do not know the mechanics that lead to this formation. With the James Webb Telescope, scientists will make visible the formation of stars in molecular clouds. They will also understand how huge bursts of star formation are triggered when galaxies merge together. Also, monitoring the formation of young stars could also advance knowledge of the formation of planets around them. These results may help scientists understand how our solar system was formed. If you're wondering what the planets that revolve around stars other than the sun look like, the James Webb Telescope could be the answer to your unanswered question. To date, no fewer than 4,977 exoplanets have been discovered. If a lot of information has already reached us, we know very little about the composition of their atmosphere. The James Webb Telescope, with its infrared sensitivity, could thus make it possible to find out more by analyzing the light which crosses these atmospheres. With the James Webb Telescope, scientists are going to discover the existence of quite complex molecules in places that they cannot imagine. The James Webb Space Telescope could also advance research on researchers' big question: where did life in the universe come from? The basic assumption of scientists today is that life originated on Earth, but in fact, we do not really know if that's the case. Today, these discoveries are still dependent on many factors, and in the first place, the success of the launch and the deployment of the telescope, one of the most ambitious challenges ever taken up. Nearly 350 potential failure points were counted, which is 3 times more than when the Perseverance rover landed on Mars. If these steps are successfully completed, it will take quite some time to make the first observations, the first results of which should be known in no distant time. So that concludes today's video. If you found the video helpful, give us a thumbs up, and don't forget to share the video with your friends. Also, let us know in the comment section what you think about the recent observations of our galaxy made with the James Webb Telescope. Thanks for watching, and see you next time.